Welcome to Module 7 Deep Learning. Deep learning is a subset of machine learning that involves neural networks with many layers, hence the term deep. It has gained significant attention due to its ability to handle vast amounts of data, identify intricate patterns, and solve complex tasks such as image recognition, speech processing, and natural language understanding. Deep learning models have revolutionized fields such as computer vision, natural language processing, and artificial intelligence. In this module, we will cover the foundations of deep learning, the types of neural networks, and their applications, along with the practical aspects of training deep learning models. Key concepts in deep learning. 1. Neural networks. A neural network is composed of layers of interconnected neurons that simulate how the human brain processes information. It consists of an input layer, one or more hidden layers, and an output layer. Neurons. A neuron in a neural network receives inputs, processes them using a mathematical function, and produces an output. Each neuron has a weight, importance of the input, and a bias, shifting the output, that are learned during training. Under the neurons we have activation function. The activation function determines whether a neuron should be activated, fired, or not. Common activation functions include sigmoid, produces values between 0 and 1. Real U, rectified linear unit outputs the input if it's positive, otherwise, it outputs 0. Tan, hyperbolic tangent produces values between -1 and 1. Feed-forward neural networks, FNN. This is the simplest form of a neural network where the data moves in one direction, from the input layer to the output layer through the hidden layers. Backpropagation. Backpropagation is the process through which a neural network learns. It involves calculating the error, difference between predicted and actual output, and propagating this error backward through the network to update the weights and biases. 2 convolutional neural networks, CNNs. CNNs are specialized deep learning models used primarily in image recognition and computer vision tasks. They are designed to automatically and adaptively learn spatial hierarchies of features from input images. Convolutional layers. These layers apply filters, also known as kernels, to the input to create feature maps. The filters detect various patterns like edges, textures, and shapes. Pooling layers. Pooling layers reduce the dimensionality of the feature maps while preserving the important information. Max pooling is a common pooling operation where the maximum value from each region is selected. Fully connected layers. After the convolutional and pooling layers, the network has one or more fully connected layers that perform classification or regression tasks. Example use case. Image classification. CNNs can classify objects in images, such as identifying cats, dogs, cars, etc., in photos. 3 recurrent neural networks, RNNs. RNNs are designed for sequential data, where the order of inputs matters. Unlike traditional neural networks, RNNs have connections that form cycles within the network, enabling them to retain information from previous steps. This makes them particularly useful for tasks like time series prediction, language modeling, and speech recognition. Memory. RNNs maintain a hidden state that allows them to remember information from previous time steps. Long short-term memory, LSTM. LSTM is a type of RNN that addresses the vanishing gradient problem, allowing the network to learn long-term dependencies and remember important information over long sequences. Example use case. Sentiment analysis. An RNN can process a sequence of words in a sentence to determine if the sentiment expressed is positive or negative. 4. Generative adversarial networks, GANs. GANs consist of 2 neural networks, a generator and a discriminator, that work in opposition to each other. The generator creates fake data, e.g., images, while the discriminator attempts to distinguish between real and fake data. The goal is for the generator to learn to produce realistic data by fooling the discriminator. Training process. The generator and discriminator are trained simultaneously. As the generator improves, the discriminator becomes better at detecting fake data, which leads to improved performance on both sides. Example use case. Image generation. GANs have been used to generate highly realistic images, such as creating new faces or artworks based on the training data. 5 deep learning frameworks. Several libraries and frameworks have been developed to simplify the implementation and training of deep learning models. Some popular deep learning frameworks include TensorFlow. Developed by Google, TensorFlow is an open-source framework that supports a wide range of machine learning and deep learning tasks. Keras. Keras is a high-level neural networks API that runs on top of TensorFlow. It simplifies building, training, and evaluating deep learning models. PyTorch. Developed by Facebook, PyTorch is another popular deep learning framework that is known for its dynamic computational graph and ease of use, particularly for research. Example use case. Image recognition. Using TensorFlow or PyTorch, you can train a convolutional neural network, CNN, to recognize objects and images. 6. Training deep learning models. Data preprocessing. Data preprocessing is critical for training deep learning models. This includes normalizing data, handling missing values, and augmenting the data, for example, rotating, flipping, or cropping images to increase the diversity of the training data. Batch processing. Deep learning models typically process data in batches to improve training efficiency and reduce memory usage. The size of each batch can affect training speed and performance. Optimization algorithms. Optimization algorithms such as stochastic gradient descent, SGD, and ATOM are used to minimize the loss function during training. These algorithms adjust the weights and biases of the neural network to reduce errors. 7 applications of deep learning. Computer vision. Deep learning has transformed the field of computer vision, enabling systems to automatically detect, recognize, and classify images and videos. Example: self-driving cars use CNNs to detect road signs, pedestrians, and obstacles. Natural language processing, NLP. Deep learning models like RNNs and transformers have advanced tasks such as machine translation, sentiment analysis, and text generation. Example: GPT, like the model you're interacting with, is based on deep learning techniques. Healthcare. Deep learning is used in medical image analysis, disease prediction, and drug discovery. Example: convolutional neural networks, CNNs, can detect tumors in X-ray images. Finance. Deep learning is used for fraud detection, stock price prediction, and credit scoring. Example: LSTMs can be used for predicting time series data such as stock prices. Glad you could make it to the end of the module. Take the quiz to continue to the next module.